Human na ta og study about the physics of moving objects. We have determined its speed, velocity, acceleration, etc. Karon, we are going to study the physics of fluids. So, in this lesson, you will be able to calculate the density of a fluid given its mass and volume, apply Pascal's law to determine pressures in fluids, and calculate the buoyant force that the fluid exerts on a body immersed in it. A fluid is any substance that can flow and change the shape of the volume that it occupies. So it primarily refers to gases and liquids. Kay tungod ang gases and liquids, it will take the shape of its volume and it flows, so they are called fluids. One important property of fluids, bisan pa og solids apil, is the density, which is defined as mass per unit volume and is given by the formula rho equals m over v, where rho stands for density, m for mass, and v for volume. Since the unit or the SI, the standard unit for mass is kilograms and volume is cubic meter, so the unit for density is kilograms per cubic meter. Mo na siya ang standard unit sa density. Another commonly used unit for density is grams per cubic cm, pero dili na siyang standard, no? We still consider kilograms per cubic meter as the standard unit. And 1 gram per cubic cm is equal to 1,000 kilograms per cubic meter. Napod tayo ginatawag nga specific gravity. This is simply the ratio of its density to the density of water at 4 degrees Celsius or 1,000 kilograms per cubic meter. Though gitawag ni siya og specific gravity, pero wala ni siya kalabutan sa gravity. The proper term for this could be relative density because we are relating the density of a material to the density of water at standard conditions. And nata diha sa table 12.1 sa atong textbook, the densities of some common substances. You have from air, ethanol, until sa density sa stars you have there. Let's have our first example. Find the mass and weight of the air at 20 degrees Celsius in a living room with a 4 meter by 5 meter floor and a ceiling of 3 meters high, and the mass and weight of an equal volume of water. Ang ato ang first target is the mass of the air. So from the formula rho equals mass over volume, we rearrange the variables. So naatay mass sa air is equal to density sa air times the volume of the air. For the density of air, naataana sa atong table, and that is equal to 1.20 kilograms per cubic meter, but wala tay value for volume. But what we know sa problem is that we have a room with the dimensions of 4 by 5 by 3. So from this, we can calculate the volume of the air as 4 times 5 times 3 equals 60 cubic meters. So we use these values sa atong formula for the mass of the air. So we have 1.20 kilograms per cubic meter times 60 cubic meter, and that is equal to 72 kilograms. So that is the mass of the air sa room, 72 kilograms. Next, weight of the air. Since weight is just mass times gravitational acceleration due to gravity, so the weight of the air is equal to 72 kilograms mo na siyang mass sa air times the constant acceleration due to gravity, 9.80 newtons per kilogram. So we have 700 newtons. Next, we are going to find the mass of an equal volume of water. So, using the same formula, mass of water equals density of water times the same volume of water. We know from the table that the density of water is 1,000 kilograms per cubic meter, and the volume of the water pareha lang daw sa volume sa air sa problem, so that is 60 cubic meters. So we substitute these values to the formula. 1,000 kilograms per cubic meter times 60 cubic meter is equal to 6.0 times 10 to the 4 kilograms. Next is the weight of an equal volume of water. So from this, using the same formula for weight, which is equal to mg, mass is 6 times 10 to the 4 kilograms, times g is 9.8 newtons per kilogram, so you have 5.9 times 10 to the 5 newtons.